Hello, today we are back for dependent probability. Now, dependent probability is going to be very different from independent probability because that means the chance of what happens next is going to change based on what happened before. So, dependent probability is best done by mapping your outcomes in a tree. That means we're going to be looking at what if this happens and what if this happens and what if this happens until we end up multiplying each of those possibilities together to find our final outcome. So we're back with the captain and the pirate. So we've got a captain and a pirate again. So captain and pirate. And that means that if they're having a shootout, one of them has to go first. So this says if the captain and the pirate each shoot once, so we're going to have one shot for each one, and the captain shoots first, what's the probability the captain hits the pirate ship, but the pirate ship misses? Okay, so the captain is shooting first, and so let's look and see what the chance is that she hits. Captain has a 1/2 of hitting, so I don't need to start with pirate here. Starting with captain, that means that we've got a 1 out of 2 chance of hitting, and that means we also have that 1 out of 2 chance of missing. All right, and it says, if her ship hasn't already been hit, Dread Pirate Ashley has a 1/6 of hitting the captain's ship. If her ship has been hit, Dread Pirate will always miss. So, after the captain is fired, then we have a return fire by the pirate. And if hit happens, this says that they will always miss. That means there is a 0% chance of hitting and a 100% chance of missing. And if the captain misses, then, let's see here, Dread Pirate Ashley has a 1/6 of hitting. So if there's a miss, then there's a 1/6 of hit. And that means there's a 5 out of 6 of miss. So the problem here is asking for the captain to hit and then the pirate to miss. So if the captain hits and the pirate ship misses, then we've got 100% of 1/2, or 1/2 multiplied by 1, which means our answer is simply 1/2. And mapping this out this way gives us all of the possible outcomes. So if we say, what's the chance that the captain shoots first and the captain hits but the pirate ship hits, then that would be a 0 because the captain would hit 1/2 of the time, but then we'd multiply that by the 0 for the pirate ship hitting. Or if the captain misses, again, we'd be multiplying that 1/2 miss by the pirate's accuracy. So again, a good strategy for doing these problems is to map out the outcomes by labeling them, and then we multiply those probabilities we wanted together. So we have a 1/2 hit times 100% miss means we've got 100% of 1/2, which was 1/2 for this example. All right, so our second example says, in a class of 7, there are 3 students who have done their homework. That's a bad percentage. If the teacher chooses 3 students, what is the probability that none of the 3 of them have done their homework? All right, so again, for dependent, we have a series of simple probabilities that we're all multiplying the outcomes together. So let's start with our data here. This says we've got 7 total, and we've got 3 that have done their homework, which means we have 7 minus 3, 4 that have not done their homework. So the teacher's choosing 3 students. That means we have 3 choices here. And what's the chance that none of them have done their homework? Okay, so the chance that the first one didn't do their homework is going to be 4 out of 7, because there are 4 students out of a total of 7 that have not done their homework. Okay, so after I choose that student, no matter which one of the 4 students I've chosen, after that student has been chosen, the next question is, how many are left? You see, if I've chosen one of my 4 students that didn't do their homework, then that means there's now only 3 students left that haven't done their homework. And not only that, instead of having a total of 7 other students to choose from, now I only have 6 students to choose from. So the first probability, the first chance was 4 out of 7 that I would pick a student that hadn't done their homework. But now that that one student has been chosen, both the number available and the total number of possibilities have been reduced by that one student that got picked. So now I'm down to 3 out of 6. And again, I have to ask the same question. And again, if I have made this choice already, then that means that I now only have 2 students left that have not done their homework, and 5 students total that are left in this selection. So those are all 3 of my choices. First, a 4 out of 7, and then when that student was picked, now I only have 3 left out of 6, and when that student was picked, I only had 2 left out of 5. And again, for my answers here, for all of these things happening, the first and the second and the third not having done their homework does mean I'm multiplying, and again, I am multiplying straight across here. So 4 times 3 is 12, times 2 is 24. And across the bottom, I've got 7 times 6 times 5. 5 times 6 is 30, times 7 would give me a 210. So as an unreduced fraction, a good answer would be a 24 out of 210. And you're welcome to reduce if you choose.